500 organizations. He prides himself on being a generalist with experience Python, JavaScript, networking, databases, as well as security-specific tools like Brozeek, application firewalls, network firewalls, packet analyzers, and SIEM solutions. So with further ado, I present John Smith.
Awesome. All right, let me get this screen shared for you guys. Okay, so hopefully you can see my screen. Yep, good. So again, my name is John Smith. I'm not sure what my parents were thinking. Today we're going to talk about who are the people in your neighborhood. I don't know if Sesame Street is even still on, but we're going to talk about how to track the internet's shady CIDR blocks. I have a blog. It's called Digital Vigilance. Someone had parked Digital Vigilance, so I just have digvig.com. It's easier to type anyway. I've got 2 articles today, but I will start posting more and eventually have a podcast. If you want to find me in GitHub or LinkedIn, look for Packet Jockey. That's a joke my brother used to call me when I took the job at Extra Hop Networks. Anyway, we're out NDR, or Wire Data Analytics Solution. So he calls me a Packet Jockey. A little bit more about me. So for me, in particular, this talk is going to be around DevOps, right? We're going to use Python, we're going to use Jupyter Notebooks, and a module called PANDAS. Now, for me, in my career, I've been in the industry about 23 years. This is a meme, or a very bad version of a meme, of 13th Warrior. It's probably my favorite Antonio Banderas movie, where there's a scene where he says, "I'm not a warrior," and one of the Vikings looks at him and says, "Soon you will be," right? When I came over to started working in the DevOps space, and if you don't have a lot of money, you have to leverage open source tools. Well, maybe you're not a programmer. Well, soon you will be, right? I hadn't written a line of code until probably 2012. So, a lot of times when I would look at programming, it would basically look like Egyptian hieroglyphics. Don't be afraid if that's the case. With respect to this presentation, everything that you see today will be on my GitHub site. This is going to be a project that I'm going to track here, but if you go to GitHub/PacketJockey CIDR tracking, you can actually use these. Long term, I want you to be able to just do a Git clone and be able to just run through the Jupyter Notebooks. If you're learning to code, right, #LearnToCode isn't just a way to get banned on Twitter. It is actually something that's good for your career. It's nice to see with the kind of this return of the IT generalist, right? For a long time, we'd all become really specialized, but now your next gen products have REST APIs, right? And JSON has made life a lot easier to code against. So now, we're starting to see people add the ability to just write a little bit of scripting or a little bit of code, whether that's Python, JavaScript, PowerShell, something to make your life a little bit easier. So again, today we're going to use Python. In fact, here are all the tools we're going to use today. We're going to use Jupyter Notebooks and for the different modules, Pandas, JSON, Request, NetAdder, CSV. I know we compete with Corelight, but Bro is an open source solution. I'm not sure how my company feels about that, but for the examples today, we're going to use brocon.log, but we'll talk a little bit about the different sources and iframe. And then we are going to use our product is called RevealX. I'm just going to have a couple of things that I'm going to talk about there, but we're going to talk about Shodan, a couple of different ipinfo.app. I just want to cite some of the different sources that help contribute to this. Namely, I love that AWS, DigitalOcean, and Google publish their CIDR blocks, which I think is important. Firehole is great. If you don't have a lot of money, Firehole makes a really nice way to leverage open source threat intelligence. So what led to this? This is the only thing about our product I'm going to show. Everything else will be open source. But this is a dashboard I built. Now, this one is in our attack lab. But it's basically, I call it a whack tracker or a slash tracker. I probably need to think of a different name, but we refer to CIDR blocks as /16, /20, whack 16, whack 24. And basically it is here's egress where we see a number of outbound servers that we're talking to this particular CIDR block, how many unique clients, and then how many unique flows do we have. And I'll get into why this is important, but when you start to see a bunch of persistence, right now, that doesn't necessarily have to mean it's a threat. A lot of third-party applications, a lot of your vendors will establish persistence. They don't always tell you they're doing that, but they'll do that, right? So that they can either send metrics, check licensing, that type of stuff, right? But persistence on non-RFC 1918 addresses should be investigated. If it's not a B2B partner, if it's not an approved session, then we need to peel that thread and tug on that thread and just see what unravels. Maybe it's nothing, but a lot of solutions that exist in threat intelligence spent at least 30 to 60 days not on any threat intelligence while they ran amok and then ended up getting blacklisted. So we're going to talk a little bit about that today. So if you notice here, pivoting from a PowerPoint slide into work is really difficult. So I've just kind of put the slides into the Jupyter Notebook. So now we're going to pivot directly into the Jupyter Notebook here. So again, this is a little bit of a technical session, but that said, if you can get clone this, or if you can grab those Jupyter Notebooks, if you're capable of hitting Shift Enter, then you can use this tool. Now, I learned to code by grabbing somebody else's product and then just editing it for myself. I think that's how a lot of us. I'm older. I'm a Gen Xer. I'm over 50. There weren't a lot of programming classes, so a lot of us in this generation are self-taught programmers. So here, I'm just going to walk through some of these. First thing I want to check, I just want to cover why we should be looking at particular CIDR blocks. Now, our threat research team created a list of the Sunburst threats. Now, what I'm going to do is I'm going to read this threats.json file, and I'm going to create a data frame, and I'm going to get a list of the malicious IOCs on a per/24 basis, right? And what I'm getting at here is that a lot of these IOCs, a lot of these malicious hosts are gravitating towards a few select CIDR blocks, right? And if you notice here, I've got an octet variable. If I want to make this a /16, I simply take off the last two octets. And again, here, it starts to take shape. You see that a lot of these malicious IP addresses are gravitating towards a /16. So one of the things I use to determine whether or not there's a campaign against me is if I see, persistence against a particular CIDR block. So moving on through this, let's take a look at some of the Cobalt Strike servers that were observed in Shodan. John Althouse has an algorithm called JARM, where they're able to kind of out some of these some of these Cobalt Strike servers. And if you look here, in January, there were 4,685 Cobalt Strike team servers in Shodan. In February, there were 1,639, and then obviously in March, there were 114. So now let's just take a look at and see what some of these look like, right? So here we've got a data frame. So let's see what they look like in terms of /16s. So this is the initial one in January that we're looking at. So if I go ahead and hit this should eventually populate. Hold on. Here, right? And this is a live demo, so bear with me. So here we can see this 119.5, 112.194. Again, these Cobalt Strike servers are collating around these top CIDR blocks, right? They're sort of living in a particular set of CIDR blocks. Now, if I want to look at it by port, well, first off, let's look at the February numbers. And again, you can see how they're going down. There we had several hundred, now we're down to 79. And then if I look in March, I just ran one recently, right? And I look and I see that same 119.5 is down to 6. So, so a couple of interesting things there, right? First off, that's great, but let's look at the ports that they were running on too. So if we come here, I want to look at the port. And again, all I'm doing is uncommenting different parts of my notebook here, and that's giving me back some more information about the individual. Here we've got the ISP. Here on port 10,000, 119.5 only has 6 Cobalt Strike servers. So what does that mean? Well, let's take a look at Shodan real quick, right? Right now, there's only 86 servers, okay? But let's look at something else. We saw that the port was 10,000. Right, and the network was 119.5.0.0/16. So again, at the start of March, we only had 6 Cobalt Strike servers running on port 10,000. Now, let's just look at then, there shouldn't be a lot running on port 10,000, right? Well, when I do a quick search and give this a second, here, oh, let's see what I did wrong. Net. Let's see here. Give me a sec. All right, and then let's look at port 10,000. And I'll bring this home here in a second. So we still have 154 systems on that CIDR-Block running something on port 10,000. Now, when I look here and I see that we only had 6 Cobalt Strike servers running on port 10,000, a lot of us who have had to lock horns with Cobalt Strike, they have something called the malleable C2, right? And by malleable meaning they're able to change it. Now, have they suddenly become shamed and decided to walk the righteous path and they're no longer hosting something malicious like Cobalt Strike on port 10,000? Or have they just figured out a way to evade that signature and now they're just running Cobalt Strike on Nginx or something else, right? And so this is what I'm getting at, is that just because, you know, because something matches a certain set of threat intelligence, or because we don't see Cobalt Strike running on this CIDR-Block, it doesn't mean that these people have changed their ways, right? Now we've gone, if you notice here, we've got 154 systems running on port 10,000. I'm more inclined to believe, given the industry we are in, we are sort of paid to be pessimists, right? We are what one of my colleagues calls professional haters. If you look here, initially in January, we had 199 Cobalt Strike servers running on port 10,000. And when I look at Shodan here, I'm more inclined to believe that they've just moved their, or they've just changed their C2 so that it can no longer be fingerprinted. So again, bringing this home, getting back, when you see a connection to a CIDR-Block and you see persistence to it, you know, just because it's not on a piece of threat intelligence, persistence of any kind to a remote location, whether it's external, whether it's domestic, or whether it's in China, Russia, one of the big, you know, bad actors that we lock horns with a lot, that doesn't necessarily mean that it isn't a problem, and it should always be investigated. So pivoting over here, the next slide. It's cloud, it's cool. No, it's not, and now you must die. Now, I've had some rather palpable frustrations this year with some of the folks we talked to saying, oh no, that's AWS, it's not a big deal. We don't have to worry about it. Now, this is a recorded future report. I just want to call attention to a couple of things here. First off, one of the things they said is our detections had an average of 61-day lead time before an IP address was found on open sources. Now, I don't mean to endorse any particular threat intelligence platform, but what we're getting at here is that if you're using open source, essentially this system is going to have 61 days to run amok before someone actually catches it. And again, bringing this back to the earlier narrative of why if you see persistence to a particular part of the internet or a particular CIDR-Block, just because it's not considered, just because it's not blacklisted today, anything that's blacklisted today got to enjoy some period of time where it wasn't on a blacklist. And then one of the other ones that I want to point out, because another frustration is people ignoring domestic persistence, right? If you look at the one of the other big things that they talk about, the hosting providers that had the most command and control servers in their infrastructure were all US based: Amazon, DigitalOcean, and chupa, right? So again, if you wanted to see who was the biggest threat or who had the most malicious hosted networks, that foam finger is decorated with those beautiful stars and stripes. We are still waving the foam finger. We are still #1 when it comes to hosting malicious sites on these cloud platforms. And so I just want to walk through a couple of instances of how these cloud platforms are dangerous. So again, I'm coming back to my my PANDAS instance, and I'm going to look at a couple of things here. You'll see a list of systems here, right? What I'm going to do is carve these out into CIDR blocks. Now, the first one I want to show you is this web server, firehole list, right? These are updated every minute. So I'm just going to cut them out into /24-bit networks. And what we're going to see is there are a number of, now this one includes a number of different networks. So I didn't need to chop off the first octet yet. I'm not doing that. I'm just bringing the raw data up. Sorry. So here you'll see a number of different CIDR blocks. If you do business with one of these hosting providers and your IP address, your elastic IP is in one of these ranges, then you run the risk of having your site blacklisted. Now, I've been in the industry a long time, and I can tell you what, more than once, I have gotten frustrated with a particular set of bad actors and just blocked an entire /16. Now, that's a bit rash, but it is certainly not uncommon for someone to get frustrated and just block an entire /24. That happens all the time in my 20 years of experience, where people just get frustrated and they know someone is in this CIDR block and they're engaged in no good. So that's one area where you can have a lot of frustration. So if I want to look at now, I want to do a few comparisons, and I'll cover how we got these lists in a bit. But if you look here, I've got a set of AWS CIDR blocks, and I just want to see how many AWS CIDR blocks are in this list of known bad web servers, right? So there's my AWS data. So I'm just going to do a quick PD merge. And again, this is all in GitHub. If you wanted to play with this, you could definitely do it. But I want to take a look at the matches here. So when I click here, you'll see that a large number, how many, 38 of these AWS networks or hosts are listed as known bad web servers on Firehole. If I want to get a count of them, I can also use this and get a count. It looks like there's one in each CIDR block. But the point here is that just because it's AWS, it doesn't mean that it's safe, right? There's a lot of bad actors in AWS. And like I said, one of my very big frustrations is with people ignoring cloud data. Likewise, if I want to compare to, if you notice here, I've got DO data. So this is the DigitalOcean CIDR blocks. And here's a list of the Google LLC CIDR blocks. So if I want to compare those, if I want to look at DigitalOcean, you'll see that you have even more, I think, in DigitalOcean. How many do we have there? What's the number? And these are updated every minute, so they change day by day. But there you've got 480 DigitalOcean IP addresses that are on that known bad actor list. One of the terms I've used for DigitalOcean is digital slumlord. If you've ever, my first job out of college, I was with the health department, and we had a lot of trouble with slumlords in the Phoenix area. And slumlord is basically someone that doesn't care what you're doing as long as you're paying the rent. Now, that's not fair to characterize AWS, DigitalOcean, or Google in that fashion, but there is a little bit of frustration. I understand they don't have a crystal ball, but a lot of bad activity goes on, and the assumption of reputable IP addresses because they belong to those cloud providers is not necessarily something that's true. So again, here you see with DigitalOcean, you have a large number. Now Google has kind of calmed down in the last couple of years, but if we look here, we do see a couple of Google IP addresses that lived in there that are part of that. So again, getting back to, it's not cool if it's cloud, right? A number of these bad actors currently exist in AWS, Google, DigitalOcean. So basically, we can run this comparison of known bad actors against these cloud providers. And I'm just using this section to kind of prove a point of, hey, just because it exists in these network in these particular cloud providers, it doesn't mean that they're a reputable site. Likewise, if you wanted to just use a different one, let's say we wanted to look at level 1, again here, there I see these, and if I want to go ahead and build out my block here, there we have the different blocks, right? I've converted them to /24s. And now if I want to do a quick comparison, let's see how many of them are in DigitalOcean, right? Let's look at that one. So here, DO data is my DigitalOcean data. So now I'm going to do a quick comparison. There you see a number of those are, again, in DigitalOcean, living in DigitalOcean's IP addresses. So hopefully I haven't beaten this to death, but it's not cool if it's cloud. If you see something that looks suspicious, then it needs to be investigated. Again, back to my health department days, people talk a lot about dates on the back of cans, and our philosophy on that was always, if the food is spoiled, you have to throw it out, regardless of the date on the can. If you see suspicious behavior, you need to investigate it, regardless of whether it's from a reputable site or not. So the next one. So let's do our own CIDR-Block watch, right? So we're going to do some comparisons, and we're going to use the tool against some log files to see if we can root out any bad, any malicious, or any suspect data in here. So we're going to do this first, a few things. Tracking CIDR-Block persistence, what are the sources we can use? Well, Apache or web server logs are very good, especially if you want to look at ingress. Do you have someone trying to upload web shells on your system, something like that? Build up and tear down, if you've used, I don't know what the, I was an ASA guy back in the day. I don't know what the Palo logs look like, but those firewall logs can also be very valuable, as can proxy logs. And then there's also REST API sources, right? Again, with the move away from XML over to JSON, it really has made programming and consolidating and federating this data much easier, especially when you use a solution like PANDAS. So any REST API source can be leveraged as a data source to do some comparisons with. And then obviously Bro Zeek logs, which is what we're going to use today. We're going to use con.log, but these logs, again, looking at that connectivity, can also be very valuable as well. So let's walk through and look at some of these. Now, here's an example of DigitalOcean. So DigitalOcean publishes their CIDR blocks. You should be tracking their CIDR blocks. I know that they're about to go public, I think. Look, I'm sure they have some reputable people working there. But the truth is, I'm not the only, and I'm certainly not the first security professional to get frustrated with DigitalOcean, right? So I'm going to go ahead and come in here, and I'm going to build out, I'm going to build or create a data frame out of this DigitalOcean CSV that they've published. So if I want to look at that, if I want to see what that looks like, right, I can just come here and type CIDR, and I should publish. So there's a list of all the DigitalOcean data frames. Now, if you look here, some of them are /18/22. So for me, what I'm going to do is use a NetAdder Python module to convert all of those into /24s, right? So we will convert all of these, all of those supernets into 24-bit CIDR blocks. And then that will give us a list of all of the DigitalOcean CIDR blocks. And this is going to take a second, but I'm basically converting thousands of networks into /24s. So there we have the first 3 octets. And what I'm doing here, the goal isn't to necessarily create a Sev1 incident so much as it is to give your threat intelligence and your incident responders a thread, and your threat hunters a thread to tug on just to see what unravels. So I have all of my DigitalOcean CIDR blocks as a /24, and then I take conlog from Bro, and I convert that into a /24, or I grab the first 3 octets. And what I'm doing there is I'm comparing the first 3 octets of con.log with the first 3 octets of DigitalOcean. And I'm getting, as you can see below, sorry, I'm getting if you look here, you'll see 103, 104, 105, 106. They have several thousand persistent connections to a DigitalOcean CIDR block. This is the kind of thing that you need. This is the kind of thread that we want to tug. And again, we're leveraging PANDAS, a free product. We're leveraging our Bro Conlog, another free product, and we're able to do some nice intelligence. 4,000 connections to any external CIDR block, especially DigitalOcean, or let's say it's Spectrum or Comcast or Bright House, right? Those are probably not B2B partners. Now, it's possible someone's hosting something on DigitalOcean, but I want to find out. I want to peel that back, and I want to see what process is running this persistence, who is it talking to? Because again, as we talked about earlier, a significant number, in fact, if we go back to this recorded future study here, right? Monitoring only suspicious hosting providers can leave blind spots, as 33% of C2s observed by recorded future were hosted in the United States, many by reputable providers, right? So again, coming back to this, if you notice persistence with any CIDR block that's external, you need to peel that thread, tug on that thread, and let's see what unravels, because a lot of shady business goes on in a lot of reputable places. Likewise, I want to pivot over to AWS. So here, again, kind of the same thing. I won't rehash it, but I've got a list of AWS CIDRs, and I can come here, I create this CSV file, and I make a data frame out of it. And if you look here, here's my data frame, and it's very large, but there are 208,000/24s in the EC2, in the Amazon EC2 space, which is their hosting space. And the great thing about PANDAS is that I can PD merge these. I can PD merge almost 1 million records with my Bro Conlog, and this gives me a list of all of the connections that are going to AWS. Well, one system going to AWS, and in fact, I think a lot of I see a ton of traffic going out to AWS. What I'm looking for specifically is, do I have persistence? And in this case, this is a sample con.log, but if you have a single IP making like 600,000 persistent connections, right? That's where you'll want to, sort of tug that back. Hey, what is this? Is this a B2B partner? Again, as I said earlier, too often we tend to ignore when there's a persistent connection and it's not a blacklisted site. So again, any persistence going to a non-RFC, RFC 1918 address should be investigated. So I'm going to make this a little faster, but I'm going to just go through Google LLC real quick. So again, same thing with Google. Google publishes, here's a couple of links, and again, these are in the Git repo, a couple of links to the Google IP ranges. There's a lot of persistence. There's a lot of bad actors running in Google LLC. So again, I walk through, I create a data frame out of those Google IP addresses. I convert them to 24-bit CIDR blocks. And then again, as we did earlier, I take my conlog and I'm looking for persistence with any Google LLC IP address. So if I click here, you'll see I have a significant number of connections. So if I want to do a quick group by, I can see that. Okay, and if you speaking of Sesame Street, like one of these kids is not like the others. There you see a spike in persistence here with this IP on this particular CIDR block. So again, we want to be able to track persistence with these cloud providers because they've really become kind of a menace. And just because they're reputable doesn't mean that someone isn't doing something wrong. Now, in the case of Google, DigitalOcean, and AWS, as I said earlier, I agree they don't have a crystal ball, but that said, we do want to make sure that we monitor them because bad actors do purchase space from them and they do engage in malicious activity. One other thing I'd like to point out here, this is the additional research from Sunburst, right? And again, here we are back with the CIDR blocks. This is an AWS CIDR block right here. That one might be, it's interesting when you've been in this industry this long, certain first octets raise your hackles. If I see 185 or 5, right, I start to immediately think, oh, this is malicious, right? So you learn certain CIDR blocks or certain octets that raise your hackles. Here again, we're seeing that there are a number of CIDR blocks that participated, and we saw that earlier when we pivoted over to the emerging threats. I'm sorry, the threat research team, when we looked at some of the Sunburst data. And again, here you see there's sort of, especially near the top, a lot of bad actors are looming around that top area. Then when we come here, let's see, when we come here, you'll see also FireEye sighting. Again, these are in DNS responses, but again, this is where the bad actors live. And more observing and being able to track these external CIDR blocks is very, very, very important. So moving into, let's see, where are we? Right here. So the last PANDAS one that I want to show here real quick. We're looking at, I'm looking at this abuseat.org. This is I believe the CIA's fact book of the most infected networks on the internet. So here you look, you'll see this particular one, I believe that's India, this 45271. This has 15% of the hosts are infected. So I want to go ahead and create a data frame out of that, convert those into 24-bit blocks, and do some comparisons there. So here we see 45271. So I'm going to go ahead and hit Shift Enter. And where this is going to go, it's going to go out to this website here, right? And this is a really useful website. So this gives me a list of all the CIDR blocks that are in this known bad ASN. Long term, what I would like this project to do is map everything to an ASN, right? And not so much, I want to get out of converting these to 24-bit blocks and comparing the first 3 octets. I was using an API for that. And then I inadvertently sent 40,000 requests, and now I'm in the process of trying to beg my API key back. I'm going to try it with MaxMind to do some mashing up here internally, and hopefully that'll get a little bit better. But for today, we're comparing the first 3 octets. So here I've got this list on this ASN of several CIDR blocks. I'm going to go ahead, as we said earlier, I'm going to convert these to 24-bit blocks. And if you look, that makes a lot of them. But here, now I've got the first 3 octets of every single address in that known bad. And if you look, right, they have 2,534/24 IP addresses. And that's a lot of room to do a lot of bad stuff. And they can move, a bad actor can move around as well. So now I'm going to go ahead and I'm going to compare. I've done some crafty find and replace, right? So I've sort of rigged the results. But now I can come here and see, oops, let's see. In this case, I guess I don't. There we go. All right. So here, I've looked at my con log. I created a data frame. And now I'm doing something called PD merge. And that's giving me a list of all of the persistence. And again, if I want to group by so I could get a high level look at this, I come here and I see 42 connections to 112.110.120. And again, this is 42 connections to a known bad ASN. Now, if you are a developer or a programmer, when you look at this, programming this to happen automatically or periodically or every few hours, right, is not that difficult. It's not that big of a reach. And you could check several dozen known blacklists against your logs to be able to see, you know, hey, do I have any persistence that I need to peel the onion back on? And that's kind of the goal of what I want to show here. I didn't want to teach a PANDAS class here. The only expectation I would have is that you'd be able to click Shift Enter while you use this. But that said, hopefully a latent function here is that you can learn a little bit more about PANDAS and learn how you can leverage it. A lot of your big cybersecurity startups, a lot of your big, really sexy machine learning companies, they're using PANDAS. And you might think that that's out of your reach, or, when I worked in security, when I was a government employee, there wasn't always money. And so you used open source for things like this. And my point is, things like Grow, things like PANDAS, right? These are free, and you can use the same weapons that Fortune or that future 50 cybersecurity companies use. These are all readily available. From a career standpoint, anything you can learn, that anything you do to add a programming language to your skill set will absolutely forward your career. It will make you a very key person. If you've been in the SOC and you're getting a little burnt out, adding a little bit of DevOps skills, that can be really valuable. If this looks like Egyptian hieroglyphics, right? All I can tell you is that it did to me when I first started learning to program too. And just kind of look at it, and eventually you learn to edit other people's code, and from there, you can build some new skills. So I realize this may have been a little bit of a complicated presentation, but again, the only thing you would have to do to use this is clone these libraries, run Jupyter notebooks, and then hit Shift Enter, and then hopefully through the process of this, you can maybe develop a few more Python related skills. But there's a lot of open source threat intelligence, and if you've got logs and you've got a list of bad guys, there are tools, free tools like that will help you sort of mash that up and do some really interesting threat hunting. And as you saw earlier, we took nearly 1 million records, did a PD merge and merged those and matched up those bad actors within, and this is on a Mac with 16 gigs of RAM. You don't need a super huge system. It's very fast, and it can yield some really nice results. So in closing, before we open it up to questions, first off, thank you. I know that this is different. Normally I do slides, but I kind of wanted to do a practicum or something where we actually use the Jupyter notebook. But a few things that I have as a call to action. First off, as an industry, I would like to see us sort of demand that cloud providers do a little more in terms of accountability. As I said earlier, I know they don't have a crystal ball, but I do think that it's important that cloud providers, my frustration with DigitalOcean especially, that they would be maybe a little bit more responsible about the type of activity that goes on there. Don't give people a laundry list of things they have to do to file a complaint. I would like to see cloud providers actively going out and looking for people who are misbehaving. I think that's fair. I think that there should be sort of a nice lease agreement when you agree to host your stuff at a cloud provider, that at least within your CIDR-Block, you can expect everyone to behave in a certain way. Because like I said, more than once I've gotten angry and blocked an entire CIDR-Block because I just got fed up with them. I would like to see them offer fortified hosting blocks. And what I mean by that is your Elastic IP is X, and in this CIDR-Block, we guarantee you that there will be no BS going on. I think that's fair, right? That's why if I want to rent an apartment in a building and I want to have the expectation that everyone there is going to behave a certain way because we all got to live together. Well, it's the cloud and we've all got to live together, right? So, so I'd like to see, and I would be willing to pay as a consumer more to know that I'm in a fortified hosting block. Know who your neighbors are. We went earlier to that firehole example, right? Where, again, here with these web server blocks, know who your neighbors are. Because if there's a bunch of bad actors, I had a blog on GoDaddy that kept getting blacklisted. Well, I finally got fed up and just took it down. And I don't have a, look, I understand GoDaddy has a hard job. They have a lot of stuff that they're working on. But I ended up just having to, I moved it over to Medium. But the original blog, I ended up taking down wiredata.net because I literally kept getting blacklisted. And I would have to go through this long, process with Google to get it taken off. So that's also challenging. So know who your neighbors are. Track persistence. Again, it's not cool just because it's cloud. And Recorded Future is very reputable. Falcon X says the same thing from CrowdStrike. There are a lot of malicious actors on what you would assume to be reputable hosting providers. Also, please, again, remember the foam finger is colored in stars and stripes. Do not ignore domestic persistence. That's something, again, I've been looking at packets now for probably 15 years and working with people and showing them some of the stuff that we derive from the network. Please don't ignore persistence, regardless of where it is. Obviously, if you don't do business in Belarus or a CIS-Block country, you want to tug that thread, but keep in mind the U.S. is still #1 when it comes to malicious hosting providers. And then know what your sources are, right? Know where you have some intelligence. And hopefully we've seen here today, it's not that difficult. If you've got, a gigabyte of Apache logs, then it might take a few minutes to run that, but it might be worth it to do some comparisons with known bad actors. And any API exposed intel, in your SIM, leverage those data sources and find ways that you can compare those with some of the open source. And I guess lastly, I didn't cite it here, but guys, PANDAS is great. Data science is great. I know it's sort of become a drinking game now, especially machine learning has totally become the InfoSec drinking game. But that said, you can leverage a lot of these tools that really sexy cybersecurity startups use, and you don't have to pay a lot of money. And if you want to get started, you can clone my Git repo, and if you can hit Shift-Enter and type in the location of a couple of log files, right, then you'll be fine. Lastly, what I will say, if you want to reach out to me anytime. I will not try to sell you RevealX. I will not do a sales call. If you want to walk through this with some of your data, I will happily do that with you. I'm happy to mentor anyone who's looking to get off the SOC and get into more of the architecture role. I'm happy to do that as well. So anyway, with that, I want to hand back the floor to Chauncey. And again, thank you for being patient. This was a different presentation. This is my 4th BSides. This is the first time where I've actually done something in front of folks. Hopefully I didn't lose anybody. But again, thanks so much, guys.
Thank you, everyone, for joining the session with John Smith. Hopefully all of your questions, those that had questions in Q&A, had those questions answered. Just know that John will be around, and you can always just chat him directly, and I'm sure he'll be more than happy to answer those questions. Right, John?
Absolutely. Yep.
Awesome. Awesome. All right, folks, it's 12:45. We've got 15 minutes here before our 1 o'clock presentation. And our 1 o'clock presentation will be Julie Carr, and she's up next for track 1. See you soon.